Hello, this is Mr. Stampone, and I'm going to go over how to solve exam number 2. Okay, so first things, we're looking at question 1. What stands out to me is the -3. I turn to my reference table and I see that corresponds to milli. Remember that column? You're just trying to match the number. For number 2, I'm going to do this in 2 steps. First, I'm going to go from 2 kilometers to meters, and I know that there's 1,000 meters in 1 kilometer, and so that must mean there are 2,000 meters in 2 kilometers. And then I know that there are 1,000 millimeters in 1 meter, and so I would do 2,000 times 1,000 to get 2 million as my answer. All right, for number 3, I'm going to, so I'm told that the acceleration is inversely proportional to the mass. So one way I can do this is I can say, well, 1 divided by 1/2 is equal to 2. And so my acceleration would double. All right, for number 4, I'm told that the force is inversely proportional to the distance squared. Right? So I'm going to replace r with 3r, or with 3. So if 1 over 3 squared gives you 1/9. So the answer is A. All right? And number 5, I've got that the mass is tripled and that v is doubled. So I have 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. All right, so now we're on to the actual Unit 2 content. So I have a billiard ball. It starts at this position. It goes 23 centimeters in the positive direction, hits the cushion, goes back 23 centimeters, and finally comes to rest 7 centimeters behind its original position. For total displacement, I just care about where it starts, the initial position, and where it ends, the final position. And because we're going in the negative direction, my displacement would be negative. So my answer is -7. All right, for number 3, the hiker starts, goes 1 kilometer south, turns, and travels 3 kilometers west, and then turns and travels 3 kilometers north. Now, since we're asked about the total distance traveled, all I have to do is add up how much total distance I went. So I have 1 plus 3 plus 3 for a total of 7 kilometers. If you're curious about this distance, from where I started to where I ended, well, stay tuned. We're going to be able to figure out that distance by the end of Unit 3. All right, for number 8, I've got an athlete. He sprints 55 meters in 6.5 seconds, then turns around, comes back the other way, 55 meters in 37.5 seconds. All right. Now to figure out the average speed, right? So average speed is the distance traveled divided by the total time. So he goes a total of 110 meters in 6.5 plus 37.5 seconds. So 44 seconds. I divide them. So I do 110 divided by 44, and I get 2.5 meters per second. All right, on to question 9. It's a very similar setup. 55 meters in 6.5 seconds, turns around, comes back in 37.5 seconds. But, I mean, it's probably not the exact same answer, and we know that because now we're asked about average velocity. Average velocity is the displacement divided by the total time. And the displacement, because I start and end at the same position, is equal to 0 meters. So even though it still takes me 44 seconds to do it, the average velocity is 0 meters per second. All right, if I make a graph of position versus time, the y-intercept is always going to have the same units as the vertical axis. And you'll see I put meters for all of them. The units for the slope are going to be the units of the rise divided by the units of the run, which should be meters and seconds. So the answer is B. Number 11, a velocity versus time graph has a positive slope and a positive y-intercept. I say we draw it, so we have V versus T. It has a positive y-intercept and a positive slope. So we see, is the velocity decreasing? No way. According to our graph, it is increasing. The velocity also isn't constant. And so we're left with answer choice D, that it is increasing in the positive direction. All right, number 12. So a car accelerates from rest to 25 meters per second in the positive x direction in 2.5 seconds. So V initial is 0 meters per second. V final is 25 meters per second. And T is 2.5 seconds. So if I find the change in V, I would do V final minus V initial. Then I would divide it by T, and that would tell me the acceleration. So I have 25 minus 0. So I have 25 meters per second divided by 2.5 seconds. And it's in the positive direction. And so our answer is, where is it? It is A, 10 meters per second squared in the plus x direction. All right, 13, similar, except now we're told V initial is 12 meters per second. V final is 8 meters per second. And T is 2 seconds. Now when I find the change in velocity, final minus initial, I get negative 4 meters per second squared. I'm sorry, negative 4 meters per second squared. And so I need to do negative 4 meters per second squared divided by 2 seconds, and I get negative 2 meters per second squared, which corresponds to in the negative x direction. It's negative because we're slowing down. If we're initially going in the plus direction and we go to a smaller velocity, that must mean that our acceleration is in the opposite direction. All right, number 14. Again, we want a velocity versus time graph for an object dropped at rest. So the first thing I would do is I would come up with what the, how I can include the dropped at rest part. Dropped at rest means that the initial velocity, VI, should be equal to 0 meters per second. That corresponds to the y-intercept equaling 0. So here's my y-intercept here. And because I'm being dropped, right, that means I need to have a negative slope. Okay, so the slope must be negative, and the y-intercept must be 0, and so I'm left with answer choice C. Okay. Question 15, which feature of a position versus time graph indicates the acceleration? So I have x versus t. I'll draw two graphs. Here's graph number 1. Here is graph number 2. And you should remember that this graph is a is equal to 0, but for the curved graph, a would be some positive number. And we just gave that a fancy term. We called it the concavity. The concavity is not the same thing as the area. Remember, the area of a position versus time graph doesn't tell you anything special. All right, for 16, all right, we are given information. We're told that VI equals 0, starts from rest. D equals 490 meters. And we see fall freely, which tells us that A equals negative 9.81 meters per second squared. Okay. We would also say that d is a negative number because we're falling down. All right. Our unknown we're trying to solve for is the time. Our equation would be something that has d, v, a, and t in it. So I'd get d equals vit plus 1/2 a t squared. V initial is equal to 0, so I can get rid of that. And if I solve for t, I get 2d divided by a equals t squared, and I take the square root of both sides. I plug in my numbers, I do 2 times, the minus signs will cancel, so I have 490 meters, 9.81 meters per second squared, and I get answer choice A when I type that into the calculator. Make sure you remember to take the square root, right? So this is the answer choice you'd get if you didn't take the square root. All right, 17 is a question that threw off a lot of people. So let's go through it. We've got, for our guess, our given, VI equals 25 meters per second. And we see we're moving vertically, right? So that's your clue when you see fall freely, thrown straight up, that A equals negative 9.81 meters per second, and that T equals 1.7 seconds. And our unknown is the final speed, V final. Our equation is that V final equals V initial plus AT. And what threw off a lot of people is forgetting about the minus sign. So I have to say V final equals 25 meters per second plus negative 9.81 times 1.7. These three answers come in pairs. 25 is if you thought it didn't change at all. That would only be true for the horizontal speed. The 41.7 is what you get if you forget to include the minus sign. And 16.7 is our answer. 8.3 is what you get when you do negative 9.81 times 1.87. Sometimes it's really helpful to also think about where the wrong answers came from. All right, 18. So our given, it starts from rest, so VI equals 0, accelerates uniformly at 3.75 meters per second squared, and that distance is 8.5 meters. We're trying to solve for V final. My equation is V final squared equals V initial squared plus 2AD. Again, I can cross out V initial because it's equal to 0. I will then solve this for V final. And I plug in my numbers, 2 times 8.5 meters times 3.25 meters per second squared. And I get that the answer is B. Same thing, let's see, C is what you would get if you just multiplied A and D. D is what you get when you include the 2. All right. And number 19, a ball is thrown with the velocity of 35 meters per second at an angle of 30 degrees above the horizontal. Which quantity is equal to 0 when the ball is at its highest point in its trajectory? The only thing that will be equal to 0 is the vertical component of the ball's velocity. The acceleration of the ball is always 9.81 meters per second squared. The position of the ball at its highest point, kind of like by definition, isn't going to be equal to 0. The horizontal component is constant, so in this case, it's equal to some number. It is the vertical component, Vy, that's going to start at some positive number and decrease, and right at this point is when Vy equals 0 meters per second. But the slope, which is the acceleration, is always negative 9.81 meters per second squared. All right, number 20, just a question about air resistance. Remember, air resistance decreases height and range. So it's got to be less than, answer choice A. All right. So for number 21, the car starts with an initial velocity of 12 meters per second and comes to rest. That tells us that v final is equal to 0 meters per second. So the car's average acceleration, we would have to do final minus initial. So I get a change of negative 12 meters per second in 3.5 seconds. And I get out my calculator and I do negative 12 divided by 3.5, and I get negative 3.43 meters per second squared. The labeled graph will look something like this. So here's V, here's T. This corresponds to 12 meters per second. This corresponds to 3.5 seconds. And the area under this graph would represent the position or distance traveled of the car. For 22, again, release from rest, so V initial equals 0. We're told that after 3 seconds, its velocity is 4 meters per second. So I would do 4.0 meters per second divided by 3.0 seconds. I get 1.33 meters per second squared. Again, the labeled graph this time, it's a positive slope starting at 0. So here's V, here's T. This would be 3 seconds, and this would be 4 meters per second. And I can use this graph to calculate the distance traveled. One way to do it is to just figure out what the area is under this graph, right? Because the kinematic variable, that would be position or the distance traveled. So I would do base, so 1/2 times base, which is 3 seconds, times height, which is 4 meters per second squared, and I get 6 meters. All right, for 23, Fiegel drops an egg from 5 meters above the ground. So the acceleration is always going to be 9.81 meters per second squared down for anything that is dropped. For the time it takes for the egg to hit the ground, since this is just being dropped, all I have to do is say, since V initial is equal to 0, I would say D equals 1/2 AT squared. That means T is equal to the square root of 2D divided by A. And I would plug in 2 times 5 meters divided by 9.81 meters per second squared, take the square root, and I get 1 second. And for part C, the graph, well, it's got to have negative acceleration. That means it has to be curved, and the concavity has to point down. You could either start the parabola at some distance above the ground, or you could call where it started to be 0, as long as it curves down and away. Remember, some of you drew a graph that looks like this. Remember, that is what the velocity in the y direction versus time would look like, except it would start from 0 and then would just become an increasing, more negative number, okay? All right, for 24, so this is one that I know it definitely gave people a lot of trouble. To figure out the time of flight, we need to figure out how much time it takes for the y velocity to become 0. So V initial in the y direction is 10, and we want to know how much time it takes to get to 0. Right, and once we have that amount of time, we're going to double it. So I would say that V final equals V initial plus AT. So T is going to be equal to negative 10 meters per second squared divided by negative 9.81 meters per second squared. All right, and if I go to my calculator, I get that is 1.0119, and then I double it to get a total of, that the time of flight is 2.04 seconds. The reason why we double it is because this is just how much time it takes to get to the top. We also need to know how much time it takes to get down to the bottom. To determine the maximum height the rocket reaches, one method you can use is to use this time, but what I like to use is still using the velocities. I'll say v final squared equals v initial squared plus 2ad. V final is going to be equal to 0, and I get that d equals v initial squared divided by 2a. So I do basically 100. So I do 100 divided by 19.62. So 100 divided by 19.62, and I get 5.1 meters. All right, for C, if the vertical velocity remained 10 meters per second and the horizontal velocity was increased, so we're just increasing the horizontal velocity. Well, time of flight and maximum height remain the same. And this is because the time of flight and maximum height only depend on the vertical velocity. And if the vertical velocity remains the same, then we're not going to see any change there. But because we have increased the horizontal velocity, we will increase the range, right? So time of flight is determined by vertical velocity. Horizontal velocity with the time of flight changes the range. All right, for our last question here, so a car in a straight road starts from rest and it accelerated at 1 meter per second squared for 10 seconds. So after the first 10 seconds, we'd have v final equals v initial plus at. So I would do 10 seconds times 1 meter per second, and I get v final equals 10 meters per second. So the graph, and then the car continues at this constant speed for an additional 20 seconds. So we end up with a graph that looks something like this. So the graph, first it's increasing, and then is a constant. And this corresponds to t equals 10 seconds. And this corresponds to v equals 10 meters per second. So we've done A, we've done B. For C, again, I can think of this as calculating the area under the graph here. So that's a triangle. So I would do 1/2 base times height. So 1/2 times 10 seconds times 10 meters per second. And that gives me 50 meters. So this area would be 50 meters. Then, if I want to figure out in the first 30 seconds, well, I now have to figure out what is the area of this rectangle. So I would do base times height, so 20 seconds, times 10 meters per second. And so I do, let's see, 20 times 10, that is 200 meters. Right, and that is the area here. And then I add them together. So the total distance in the first 30 seconds would be 250 meters. In the first 10 seconds is just 50 meters. All right, so that is your answer guide to the exam. Thanks for watching.